This week, we welcome David Asraf. He's the C++ developer, or a C++ developer, I should say, at Vicarious, and Roy Cohen, the co-founder and VP of Sales at Vicarious, to discuss the Patchless Horseman. That's right, patching without patching. In our second segment, we welcome back Sumedh Thakar, President and Chief Product Officer at Qualys, to talk about building security into the DevOps lifecycle. In the security news, Cisco patches a critical vulnerability in Jabber for Windows. I'm calling this one a cross-site scripting remote code execution. Stay tuned for that. Expert found multiple issues in MoFi routers. Team TNT gains full remote takeover of cloud instances using an off-the-shelf management tool. A Bluetooth bug opens devices to man-in-the-middle attacks, and a former NSA chief, General Keith Alexander, is now on Amazon's board. And the legality of security and research is being decided in the U.S. Supreme Court. All that and more on this episode of Paul's Security Weekly.
This is Security Weekly, for security professionals, by security professionals. Broadcasting live from G-Unit Studios in Rhode Island, it's the show where exploits run wild, packets aren't the only things getting sniffed, and the cocktails flow steady. It's Paul's Security Weekly. Hackers attack systems that are not patched. You need protection, but virtual patching isn't working. That's why you go patchless. Topia analyzes, prioritizes, and remediates vulnerabilities before they're exploited. Even the 0 days, all from one interface. Security gets better memory defense to complement endpoint strategy while improving overall vulnerability management and compliance. Adopt a hacker's mindset, eliminate vulnerability. Get your 30-day free trial at securityweekly.com/vicarious. Are you an enterprise dissatisfied with overpriced analytics software that can't keep up with modern data? If so, then GravWell is the solution for you. GravWell is an unstructured data analytics platform for enterprises who demand total data visibility across their network. GravWell lets your security team go beyond the SIM and fuse data sources to correlate and answer questions you didn't know needed to be asked. Go to gravwell.io/securityweekly for an unlimited data trial and gain uncompromising visibility today. Elastic Security empowers security teams everywhere to prevent, detect, and respond to threats quickly through a unified solution. And it's free and open, putting you in control. Use Elastic Security to eliminate blind spots by analyzing all of your data, no matter its volume, format, or age. Stop threats at scale with automated threat and anomaly detection. And arm every analyst with fast search and integrated case management. Download or try Elastic SIM for free and experience the benefits of an open security solution backed by world-class security research at securityweekly.com/elastic.
And welcome to the show. But first, let me introduce you to a man who likes his sexual partners like he likes his coffee. Big and cold. Mr. Possidori.
Welcome, everyone. It's episode number 666, believe it or not. I guess this is going to be one hell of an episode. I guess.
Nice.
I'm just full of the dad jokes. It is being recorded on September 10th, 2020, right here in G-Unit Studios in Rhode Island, where we welcome Mr. Larry Pesce.
In studio for the first time in a long time.
It's good to see you, my friend.
It's like 7 months,
right?
7 months, something like that. Yeah, it's been interesting. It's good to be back for
yes.
at least anyway.
Nice to have you back.
Yep, we're gonna take it week by week, and
yeah, it's good stuff. On the lines remotely, Mr. Tyler Robinson is here with us. Tyler, welcome.
Thank you very much. Glad I made it.
Mr. Jeff Mann is here with us as well. Jeff, welcome.
What you should have said, Paul, is this will be a beastly episode.
Right.
And Larry, I'm extremely jealous that you're in studio.
Yeah, I was commenting earlier that it's like the first time I've actually interacted with humans in months. So it's been interesting, aside from my family, that is.
Right.
Nice.
We're waiting on Joff. I think he's joining at 7. Okay. There's no other hosts on there that I can't see, right?
Tyler?
Yeah, I got Tyler and Jeff.
You did?
Okay.
You got Tyler.
Excellent. Let's see. A quick announcement. Join the Security Weekly mailing list. and our Discord channel, and subscribe to all of our shows by visiting securityweekly.com/subscribe. Click the join button to join that list, and visit securityweekly.com/guests. If you've got a suggestion for the show, for a topic or guest, you can use the form at securityweekly.com/guests, and we will review those and hopefully get people on the show that you requested. David Asraf is a graduate of an elite technology unit in the Israeli army and holds a BSc in computer science. He has worked in various security roles and was a lead developer at Checkpoint and is currently a C++ developer at Vicarious, leading multiple research projects. David, welcome to the show.
Hey, Paul. Nice to be here.
Yes, nice to have you, David. Roy Cohen is, of course, a cybersecurity expert with over 15 years of experience. It's not his first time on the show. He's been on a few times. So, Roy, it's nice to have you back.
Likewise. Thanks, Paul. Thanks for having me.
And for those that want to learn more about Vicarious, visit securityweekly.com/Vicarious, especially if you're tuning into this segment and you really hate applying patches, because none of us have ever been burned by applying a patch that caused something bad to happen. Right? No, everything just goes swimmingly.
Absolutely. Every time.
Every time. And patches are available for everything all the time, right?
Yeah.
And no one tells you that they can't apply a patch. Every time you go to your sysadmin teams and developers, they're like, oh, yes, absolutely. We love applying patches.
Yeah, no, reboots, no problem.
No problem. Of course, it never, ever works out that way, which is why I am so excited about this segment. So, Roy, David, we'll turn it over to you.
Yeah, I think you kind of brought into the spotlight kind of the main challenge we're having here. Patches are kind of a mess. Yeah, it comes every other day. There are so many vulnerabilities, like we said in the former session. It's chaotic. There are so many of them. Patching windows are not sufficient. It becomes more and more complex. And there is a need in the market, a growing need we see, also like frustration we're getting from clients, that even automation of patches is not necessarily going to solve all of their challenges. We see always advancement on how you deploy patches and how you evaluate them, but there is a new category which is being evolved, which is kind of how you can secure an application without actually applying a patch. You know what I'm saying?
Yeah, and now, Roy, and I think the other benefit there, having worked for a vulnerability management company, I saw all the different use cases where they'd come back to me with questions about scan results and go, well, I patched that. Why is it still showing that it's vulnerable? And they're like, it must be lying. I'm like, no, it's not lying. It's telling the truth, because there's like a whole host of other situations, right? Like the system didn't reboot, or there's two different versions of the software, or the patch just didn't apply for whatever reason. And in your management software, it told you that it did apply, but it really didn't. And I mean, like, I could go on. Those are the three most popular, right? And it goes back to your point, Roy, of automating patches is great, but are we really patching 100% of the things all the time? I mean, most aren't even trying to apply patches to 100% of the things all the time, right? And then there's the times where there's a variance, right? Where things happen and it doesn't get patched. So, I mean, the challenges with applying patches, we've covered at length on these shows, and it's still a struggle for people today, which is, again, why I'm excited to have you both on the show, to talk about some very unique methods of applying those protections without having to apply the patch right away, or maybe not at all.
So, that's precise. There, just a quick story I had with one of our clients. So we actually deployed the system there. It's a funny story where you said you had the battles with the IT saying, no, this patch this vulnerability doesn't exist. So we had a client where he had, so it's kind of, he gave up. He used a scanner, which said he has like around 1 million vulnerabilities. Not exaggerating, it's the true number, or really close to 1 million vulnerabilities, open issues. And he said, look, I'm not going to handle this. I'm probably going to be get a new position in a few months. I'm not going to handle that. So he's kind of left it aside. And the new IT guy said, this is the former guy's problem. I'm not going to touch that. I'm not going to patch that. This is quite of a challenge. So what we wanted to discuss for today was to do, again, another evaluation of an exploit we mentioned before, and to discuss about new techniques and new countermeasures we have to stop threats in runtime without these kind of very aggressive changes. Eventually a patch, it's a process where you kind of stop the process. Sometimes you need to have a downtime to replace some DLLs and modules which are loaded to the memory. So we are always looking for new ways to do so. And this is what David will be showing us in the next few minutes. So
yeah, and Roy, there's another interesting scenario because when you described this to me, you said we don't have to make any changes to any of the binaries to apply these patches. And there are solutions out there that we've seen where, maybe the vendor is delaying the patch or won't patch an issue, and then there's another company or even an open source project that goes, well, we patch the binary for you or can give you a way to patch that binary and plug that hole. It's not supported by the vendor, and sometimes you're painted in a corner and you're like, well, should I do that, right? And I've never been a huge fan of unsupported third-party patching like that typically requires you modify the binary. So another reason why I like the in-memory protections that you're going to discuss tonight.
Exactly that. Imagine that eventually for in-memory protection, it's also very easy to, assuming you want to revert, because everything is being done on memory, there's no let's call it a hard-coded change. It's very easy to revert back to the first position and then, go to the old, let's call it obsolete way of working. Mm-hmm. So this is another advantage of in-memory protection, the fact that you can go in and without it, very easy, swift maneuvers, as we're going to also show through this session.
Awesome.
Yeah, so I think without further ado, David, the floor is yours.
Thank you. Okay, so let's talk a little bit, just to remind everybody what we discussed in the last session. We spoke about format string vulnerabilities, a little bit about format string, just to be on the same page to everybody. So there is a feature in some basic function that many people use in C and C++, like printf, scanf, all of these family of functions. This feature is format string. Actually, you can have input string with placeholders. These placeholders, you can recognize them by the percentage and then some kind of indication of the type. And into these placeholders, you can put parameters or locations from the memory. A format string vulnerability is when an attacker can control the format string itself, because when an attacker can change that string, he can get access to memory locations that he's not supposed to get access to, and it can both read and write from restricted locations in the memory. So we don't want the attacker to control our format strings. We're going to discuss again the AnyDesk vulnerability. It's CVE 2020-13160. In this vulnerability, there is a simple process. So I'm going to tell you a little bit about the attack, and then I'm going to show it, and also going to show a protection, in-memory protection against this vulnerability. Okay, so if there are any questions, I'll take them now. If no, I'll just dive into it.
Go for it.
Okay, cool. So in this exploit, a simple UDP packet is being sent in the AnyDesk discovery protocol. Basically, when few AnyDesk few computers with AnyDesk installed in the same network, they recognize each other and give you the option to connect to another AnyDesk computer. This is some kind of broadcasting discovery protocol. When an attacker sends a crafted UDP into this server listening for discovery broadcasting packets, it can trigger a specific issue if it uses non-UTF encoded characters inside the packet, where the AnyDesk expects to be hostname or username in a UTF-8 format. If it's non-UTF-8 format, the vulnerability is triggered, and the attacker can control the the input that goes into VSN printf, which is one of the functions that we discussed before that has this format feature. When it does that, it can change the global offset table. We're going to get into the global offset table in details in the demonstration. And from then on, it's easy to get remote code execution on the machine. We're going to show that right now. Okay, so let me share my screen and we'll just see it. Okay, can you see my screen all right?
Yes.
Yeah.
Affirmative.
So I'm going to show you the exploit itself, and we're going to open sniffer, Wireshark sniffer, to see the traffic on the 50,001 port, the discovery port. So let's open Wireshark in the background. Okay, and I also made a filter so we don't see all the other traffic. Just want to see this specific port. And okay, we can start running the exploit. We have this AnyDesk GUI, and this is the process that we're going to attack. And let's start. We're gonna open the Metasploit console, and it's an easy tool to show exploit in Kali Linux. I'm just gonna load for 1 minute. Okay. And I'm choosing the exploit. As we said, it's the specific CV 13160 in 2020. And I'm choosing some options that regarding to the version of Ubuntu that I'm going to attack. And let's check what is my IP. And we also set in that. Okay, so now we are going to activate the exploit. And just a second. Okay, so let's open a shell, and we can actually run commands inside the attacked computer.
Yay, hooray for Shell. I get excited no matter how many times I see it. I get excited.
Yeah, that was easy, right? Really straightforward. Let's take a look on the Wireshark. Oh yeah, so we see here a little bit of traffic on the port that I said before, the 50,001 port. And we can't really analyze the packet here, but we can see some clues for the exploit. If we look, we see the percentage in a few points, and it's actually an indication to the format string vulnerability. Percentage 1, it's being used within the vulnerability. In this area, there is the shellcode itself. We can't really analyze the firmware code here, but still cool to see it. Okay, so now I'm going to show the same exploit, but I'm going to stop in the middle of it and show the specific things that the attacker does in the process, in the memory. Let's just restart everything and get our environment back to the beginning. I'm going to kill all the AnyDesk processes and restart the services. As you can see, I lost the connection because I killed the process. Oh. Okay. Reset it. And let's reopen the AnyDesk GUI because we need to attack it again. Okay. So I'm going to check which process ID is the process ID for the AnyDesk. And it's a little bit too big for us to see. Okay, this is the process that we are going to attack here. And I'm going to use a cool tool named Frida Trace. It's part of the Frida project. If you heard about it, it's a cool library with many options, help security researchers, help people who like to mess around with the memory of an application. You should try it out. I'm going to, okay, I'm not going to kill Frida. I'm going to, just a second. Okay. Let's use Frida to attach to this function. As we discussed before, the VSM printf is the function that's being exploited here. With the trace that I just set up, we're going to see every time that the function is being called, we're going to see the input that the function gets. We're expecting here something else a little bit, not the usual input. We are looking for UTF-8, non-UTF-8 characters, which will trigger errors in the display. We'll see that later. And we're also going to open GDB to the same process. Okay. Now, we discussed before the global offset table. We just mentioned it. Let's take a look at the global offset table. The global offset table is actually a mechanism that helps binary to use functions that are not located within the binary. Every time that I'm using a function that is in an external library, shared object library in Linux mainly, I'm going to use the global offset table to point to the specific location in the memory that the function resides in. When the application needs a specific function, in this case X3GC, for example, it asks from the operation system. It asks where exactly this function is located, and the answer that the operation system gives back is going to be stored in this location in the global offset table. The next time that I'm going to need the same function, I'm just going to the global offset table and taking the value from there. If we are going to look at the global offset table and grep the time function, we're going to see that the location in the memory is this location, and this is the entry for the time function. I'm going to add a watch point for the time function, and continue the run here. The reason that I added the watch point here in the time function is because the attacker in this specific exploit is changing the global offset table and changing the time entry to point to the shellcode that he entered before. The reason why it's doing it specifically to the time function is because the researcher who found this vulnerability just analyzed the binary and found that the next function that's being called after the VSM printf, the problematic one, is the time function. So if we're checking, if we're running the exploit now, we're supposed to stop exactly at the point of change. So let's rerun the exploit and take a look at the thing that we found. Okay, a little bit messy. Let's look at the Frida before we go to the global offset table. We see here these errors, and we see here a normal input. This is the input for the function, and this is the valid input. But here we just get an error. The reason that we see this error is because this function cannot print this non-UTF-8 characters to our screen. It's a small indication that there is something fishy going on here.
Yeah, you're,
So,
you're bringing me back to my struggles converting from Python 2 to 3 and getting all kinds of encoding and decoding errors, which is the error that's coming up here.
Yeah, usually when we see that, we're not very happy, but in this case, it's actually something good that we're seeing these errors. It means the exploit actually is working and
Right.
we are on the trail. Let's go to the GDB. By the way, the reason that my GDB looks a little bit different is because I'm using a tool named Jeff on the GDB. It's a really cool tool that will let you have better visibility on a few things, and I really like it. The global offset tables that we showed before, it's a Jeff capability, so really cool. As we said before, we had the watch point on this location, and as you can see, there was a change in the global offset table. And also we can see the invalid UTF encoded text in name, exactly the thing that we spoke about. This is trying to, here the AnyDesk is trying to print this message into the log, but actually it's triggering the attack. Let's see if we can see the global offset table now and see the change. As you can see, it's no longer pointing to a memory location like this, like another libc function, the same area. It's pointing to a closer location, actually in our stack. The exploit actually failed now because we stopped it for so long and it messed with the timeout over there. But we saw everything, and I think we're ready to see some protection now. So let's reset the environment again. Okay, I'm going to again kill all the processes of AnyDesk, and I'm going to restart the AnyDesk service and reopen the GUI. At this point, I will ask Roy to enable the protection from the agent, from the Topia agent.
Yeah, so of course I will show it afterwards, but basically what I'm doing now is choosing the AnyDesk application over the dashboard, as we're going to see in a few minutes. Applying protection policy for David's machine. We see here Ubuntu AnyDesk. And then what happens is basically that a command is being sent from the server side to the client side to define, okay, this is the policy and these are the binaries you need to protect in memory. As we said, it is in-memory protection. And whenever we see the pieces of vulnerable code that we found in the pre-processing stage, then we're going to security in runtime. So it takes a few seconds to get approved. And I think that we're ready to go, David.
Okay, so let's try to run the exploit again. This time we don't have any watch point or anything to stop it, just the protection. Let's wait for it.
Oh, you spoiled all the attacker's fun.
That's our job. And exactly, exploit complete, but no session, no shell, nothing to be done here. Okay, so this was the demonstration. I will stop the share now, and let's talk a little bit about this attack, about the similar attacks. I'm really trying to ask more of a theoretical question. What can be done in this kind of situations? Do you have any suggestions?
I mean, aren't there already operating system protections, I would think, that protect the global offset table from being manipulated in that way, or that doesn't. That's not a operating system level thing.
Yeah, exactly. There are options that can stop this kind of modification to the global offset table. I want to. Okay, so let's just talk about it. If the AnyDesk vendor for this version, I believe in later versions they fixed that. That's version 5.5.2. If during compilation they would have enabled the railroad option, it changes the whole way that the global offset table is being populated. Instead of every time that we need something, we are asking for it and then receiving the memory location for the function. At the beginning of the application, we're asking for everything that we need.
Yeah.
We get all the locations in the memory, and from that moment on, we are locking the global offset table for changes.
And and that's a GCC compiler option. Which one is that, David?
It's the railroad option. You can enable it in most compilers and just avoid these changes to the global offset table, or more accurately, make it so much harder to change.
Right. Yeah, make it less dynamic.
Yeah. So the vendor actually can do. I feel like I should say that the one thing that the vendor can do other than use all the security options during the compilation is talk about this. And I feel like sometimes the new developer needs to be educated to understand the vulnerabilities and how they work. And for example, explain about common attacks and how they work, giving some examples could change a lot of things. This simple option, the railroad, is something that every developer that would hear about it once will want to use it in every future application. So education, I think, is something that every vendor should give to his developers. Secure education.
Also, David, along those lines, in that code base, having a function that either tests or encodes or decodes the data into a format that you expect before you then go write it off to the logs with sprintf or similar function, right?
Exactly. And never get outside input into your format string,
right?
No matter if you trust the source or not.
Yes, agreed.
Likely.
Because there'll always be that time when that source can't be trusted.
Mm-hmm.
So let's say that the vendor already released the application and we want to defend it in the customer site. Another thing we can do, the first thing we can do is to defend the network of the customer. We can install firewalls, IPS solution, DPI solution. Basically trying to look at the incoming traffic and classify the traffic and looking for patterns in the incoming packets. Exploit patterns is something that Deep Packet Inspection, DPI, is trying to do. All these network components are really important, but I think that it will help to prevent many attacks. But this kind of attack that is using unique protocol to AnyDesk is not something that a security vendor, unless you spend time and researched the AnyDesk protocol, reverse engineered it, and understood what kind of input is valid and what kind of input isn't, a network solution most probably wouldn't work in that case. But it's still important to put that.
Are there protections? Are there protections in other operating systems such as like Windows, where they're using like ASLR, or they're using some like bottom-up memory verification, or even like compiling the compiler hardening flags, where if it gets overwritten, it just doesn't run, and that overflow doesn't do anything in the app. Like, does the operating system matter as far as how this protection can be addressed?
Most modern operation systems have all these features that you just mentioned, ASLR and NXT and stuff like that. But the problem is that not always these options are on. And if you don't enable ASLR in your operation system, it doesn't matter if it supports it or not. So
does the like x86 to 64-bit architecture, does any of that play into additional functions or features or security options for kind of where you guys are going?
In our product, actually, some of it doesn't really matter the architecture. I'm going to get a little bit into our technology real soon, actually.
Yeah, but I think too, what you're saying is that if you're going to use the type of protection that is either in a compile time or either baked into the operating system, you have to rely on two things. You have to rely that the creator of the software enabled those flags in all the versions, that you're running or will be running, that at compile time enabled these extra security options, which may not always be the case. And two, you have to rely on an operating system feature that it's enabled, hasn't been disabled in some capacity, right? So you're relying on really two external components to make sure someone can't exploit a vulnerability on your system, which is a little risky.
So what, Paul? It's actually pretty easy to check a binary that you get and see if all the compilation options were compiled into it. Mm-hmm. And as a customer, I think you can demand that things like this would be done to the software. It's nothing really hard for the vendor to do. Right. And I think that the more people would be aware of these options, the more easy it will be to put pressure on the vendors and just change that. Not releasing the software without simple compilation options is, I think, something that should be done and should be the only way that the vendor releases anything.
Right. I mean, and we all run open source software, right? And then it's up to the people who run the open source project to make sure that's there. And then they're going to release a build where they had to take that out because it caused some kind of problem, right? And now you're exposed to that vulnerability.
And that's even if you don't have an easy way to get around a lot of those protections, right? Like you can bypass ASLR, you can bypass the memory locations, you can find pointer leaks that are available. So
we have a story this week, actually.
Still do it.
We have a research paper that's using Spectral-Like vulnerabilities to bypass ASLR. So.
ASLR is not perfect. That's true. But if you are using ASLR in your system, you're not the best of targets for an attacker. If you're trying to attack someone randomly, try to make yourself as protected as possible. Mm-hmm. That's my way of thinking. And other than that, there are a lot more options that can be done in the operation system level. But you're actually taking me to the next point, what we call in-memory protection or patch injection. So if there's a vulnerability, non-vulnerability, we can create a patch in the traditional way and release new binaries and do that. And we can do the same thing with in-memory patching. We can create a patch. We can inject the patch into the vulnerable section. It also takes time to develop this kind of patch, but the deployment of this kind of patches is a lot easier.
So are you injecting the patch into the running process in memory, or are you just monitoring that running process and then stopping when this particular exploit happens?
In our case, in the protection you just saw, it was an injection of protection into the memory of the AnyDesk process, and the application kept on going as if nothing really happened. It just wasn't vulnerable anymore to that specific exploit.
And so, are you? How does that work without giving away like the secret sauce, like at a high level?
Okay, so in our case, it's something. It's more of a patch generation. So, for example, we discussed in the last session. We talked about algorithms. I wasn't there, but you talked about algorithms that are being used in our products to find specific patterns that point to possible vulnerabilities. If you take the same algorithms that can detect possible vulnerabilities, you can create similar algorithms that patch this point. So our software actually looking for with all kind of pattern recognition and binary analysis, looking for possible vulnerabilities. We take analysis of one vulnerability and try to apply it to other products. And when we have the solution for a specific pattern, we can insert this pattern, inject this patch into different kind of application that meet the same pattern.
So your protections are also somewhat a little more universal, right? Like, is this protection specific to AnyDesk, or if other similar Linux software basically has a similar or the same kind of bug, you could conceivably apply that same protection?
Exactly. If we see the same kind of pattern, we can put the same protection in the location of the different vulnerability. The rule that protects against the vulnerability is not unique to AnyDesk in any way.
Gotcha.
Just see a specific pattern and fix it. Another thing that really I really want to mention is that sometimes a vendor releases a patch to a software, and attackers analyzes this patch that was released, and they just see, okay, so something like, for example, our format string was detected in this AnyDesk. So let's try and find other places in the same software that are vulnerable in the same way. So sometimes when a vendor releases a patch, actually you can see that after a few days there is another patch and another patch to a different product of the same vendor or sometimes even in the same product, because it's easier to look for those vulnerabilities now.
Well, yeah, and David, I mean, that makes sense, because if a developer didn't know about that they were introducing a format string vulnerability, in other points in the code when they write to the logs, they're going to have the same vulnerability, but the researcher just found this one instance of it. The vendors that are more diligent will go through their whole code base and go, all right, where else could we possibly have this vulnerability, and patch all instances. But oftentimes, sometimes that doesn't happen, I should say. I think vendors are better about that today than they were years ago, but...
Yeah, so in our case, even if they don't do that, and we see the same pattern in different areas in the same product or other product of the same vendor, we can just apply the same patch.
Right, it's awesome. In that sense, it's a much better patch, quite honestly, because you're not as reliant on all these other factors, right? You're not as reliant on did they fix it in all the areas of the code? Did they compile this version with the appropriate protections? Did my, sysadmin and IT team or my DevOps team enable the security protections in Linux that maybe could prevent against this? Maybe on some systems that's disabled, other systems it's enabled, right? In all those other scenarios, you're kind of relying on other third parties to apply security for you. In your model where you're like, well, if we see this type of vulnerability, we can protect it. I like that option a lot better because I'm not relying on other people to make the right decision.
Yeah, that's exactly what we do. I think I'm gonna hand over the mic to Roy. You wanna continue from here?
Yeah, thanks, David. I think you did an excellent job here. Just wanted to keep on the following thread of mindset. So yeah, we discussed about the fact that vendors release patches and then researchers go investigate that, look like, you do a bin diff, you search for the locations which are changed, and then you're going to search for other places in the code or other products that in potential may be compromised. But our vision here is kind of something even a bit bigger than just fixing a given application or a given set of products. We're trying to identify a weakness, a weak spot in one vendor and, try to heal the community. So we had some issues or some vulnerabilities that we found in, not mentioning names, but a database application. And we saw that one vendor probably got a bigger team of developers and they were able to cope with vulnerabilities far faster than the others. But the vulnerabilities, the conceptual vulnerabilities also resided under database engines. So we were able to project, first of all, the vulnerability pattern detection to other applications, and then also the protection mechanism to other applications, which is kind of what we try to envision here. And we always try to increase the families that we are covering. This is kind of where we're aiming.
Roy, how many different types of vulnerabilities or exploitation techniques do you think you can cover today? I don't know if there's like a hard and fast number or like roughly what are we talking about in terms of numbers of different types of vulnerabilities or exploit paths?
Yeah, well, we cover a various number of families. I don't remember the exact number. For example, the one that we saw here, it's CW676, which is potentially dangerous functions. And we're also going to see this in the dashboard. So we got all these families that are increasing. We got a team of researchers that works 24/7 to add new categories. It's not an easy task, of course, to try to generalize both the detection. And then when we have a detection, we try to also to connect a protection mechanism to do a match. Sometimes it's not that trivial, obviously. This is why sometimes it takes some families do require a bit more specific, let's call it the protection mechanism. As the one we had here, the AnyDesk was a bit more specific to others because of various reasons. But we try always to build a general rule rather than going a CV by CV basis because this is not scalable.
Right. From an end user perspective, when I want to go protect a system or group of systems from a particular exploit, am I naming it by application or am I saying like protect this from format string, injection encoding issues or whatever, right? As a user, I'm selecting the application that I want to protect from what I've seen in the interface, correct?
Yeah, so maybe it's a good time to just show that. So I'll be sharing my screen here. As we can see, this is the main dashboard. Basically, when David tried to trigger the exploit and we applied the protection, so what I did as a user, so to speak, I just went and searched for AnyDesk, as you can see here. So I searched for AnyDesk, and as you can see, one of the machines is protected, the Ubuntu AnyDesk machine. Okay, so that's the one which we triggered. And by going to the operationals log, we can see that the AnyDesk was protected. And if we'll go to the, let's see here, let me just reload that. Yeah, okay, there's some loading issue. So if we see here that we saw the AnyDesk tag here. So we got the AnyDesk process and the further process name. We see the attempt, we see the family. In that case, it's a known family. And we see the type of the attack, malicious input. So this is what the user would see. By the way, if there is, so to speak, a false positive, he can allow it. He can whitelist this process. But the goal here is to know, to first to notify on an exploit and then to block it without further ado. So when you getting back to the protection, side of things. As you saw, Paul, you don't need to really go family by family. Basically, when you apply the protection, we are covering all the supported families all together. So I think it's a bit easier way. This is why, again, sometimes it takes us a bit longer to embrace new families of protection because we do the extensive checks. But this is has a very good trade-off in the sense of user experience because you don't need to go vulnerability by vulnerability. And sometimes when you try to apply, let's call it an alternative protection mechanism per vulnerability, it's kind of an equivalent for an actual patch. You do the testing, you do the evaluation. So when you have it as a whole, this is something we see very valuable. By the way, you can also see the vulnerability here that David has mentioned. And as we saw in the previous session, we also found the threats on the binary level, at least some of them and a few more. So
this is actually, for the specific vulnerability we talked about in this segment, the researcher who discovered it put together a very lengthy post, which is really awesome. Yeah, so if you're listening to this and you want like more information, like all the nitty-gritty details, it is detailed out there, and it's linked to like right from the CVE entry. So, yeah. My other question was like, if I have let's say a class of systems that I'm using to host my applications, can I just like tell Topia to like just go protect all the software on all those systems? Right? Like how generalized or granular can I be with these protections?
So I think this is also one of the topics we're going to discuss in the following session, how you define on what to protect. Because as we know, eventually, I don't think all of the users or all of the sysadmins will go and enable everything altogether. Probably they will be a bit more cautious and they try to identify which of the applications they need to focus at. And this is kind of also the third component of the system to help you to identify which of the threats that you have are the most critical ones and why. So this is kind of the third part of this loop where how you can prioritize the most critical threats. Okay, we have the mechanism, whether by patching if available or this patches protection mechanism, but how we know what we should do next? Because again, we cannot cope with everything. There will always be new vulnerabilities. Probably if we can find 0 days, there will be significantly, exponentially more than ones which are public, at least, vulnerable spots on the binary level. So we need to focus here. So one of the key components of the system is the one that checks for each and every characteristic of the running application and the properties of the vulnerability, both the known and the unknown vulnerabilities, how we can abuse them. And if it meets a certain threshold, then it makes sense to do something about. And of course, we're going to elaborate a bit about that, how you prioritize risk in companies, and then what you can do about it.
Gotcha. Yeah, that's a much better approach than just telling it to protect everything.
Yeah, you should go and patch everything,
Yeah.
Also.
No, that's really cool. More questions?
None for me. It's pretty damn cool stuff.
Yeah, that's really awesome. I want that. I need that. I need that in my life.
You need that in your computer, actually.
Yes, very much so. Supported platforms, Roy.
So we support Windows 7 and above. Of course, Windows 7 is correlated to 2008 server. As for Linux, we support CentOS, Red Hat. Now we're extending that. Hopefully Mac by the end of the month. These are the things that we are now covering.
Awesome. Yeah, so you folks are very busy.
Excellent. You scared me for a minute there when you said you support Windows 7, and I'm like, oh, please, God, please say later. Please say more than Windows 7.
Yeah, Windows 7 and later. Yes.
I still got actually last week I had a question about Windows NT, and I was like, I think we cannot help you there. Not sure anyone can. I think you should do something else. So, yeah, we do not support NT.
But Windows 7 is officially end of life?
Yes.
Yeah.
Yes, as of January.
Right. So I think
there's the extended package or something,
that
right?
You can buy probably, right? Yeah. But that's awesome. You have support on that too, as people are still obviously trying to move off of that. So having this level of protection on something that Microsoft's not issuing patches for is a huge win. I often get that question from enterprises as well. I've never gotten and haven't recently gotten NT as a supported support for that. I get XP. Like, we still have some Windows XP. Like, what's available for that, right? but that was a few
It's called
years
Windows
ago.
10. That's
Yeah,
what-
exactly. But having support for Windows 7, I think, is great because there are many enterprises that still have the older operating systems that have no support available for them unless you want to pay for it. So
That reminds
I'd
me.
rather have Vicarious.
It does beg the question, though, from a Windows 7 and support perspective. If Microsoft is not creating patches, not specifically looking for vulnerabilities in that operating system, who is? What exactly are you supporting on that operating system if nobody's researching for vulnerabilities?
It's a great question. I will just do a brief about the formal session. So the fact that we can identify vulnerabilities, first of all, it's being generated automatically. Once we categorize a family or pattern, so to speak, then we try to project it to binaries, other binaries that may contain that specific threat within. So the fact that it's a Windows 7 doesn't really, it's more related to the protection mechanism and why there are some limitations that we cannot run on older operating system, mainly because of the kernel kind of features. But as for the detection and the protection, it's the same concept, it's the same workflow. Eventually you have an MZ file if it's a Windows machine, it's a compiled binary, or an ELF if it's a Linux, and you have the same, let's call it technique, or the set of techniques that you go and hunt for the vulnerabilities. So the fact that Microsoft, or for that matter, no other vendor supports a given application doesn't affect the way that if we have this pattern, we have this technique to identify the set of families, even if it's obsolete and out of support, we can still find threats and also take care of that. So we don't need to have new exploits and new vulnerabilities disclosed for us to be able to identify threats within the binary, on the binary level.
Which
Fair enough.
It's like that's kind of interesting though, because if you are monitoring a Windows 7 system, right, that it isn't getting active patches, you put your protections on there, and you see exploits that maybe the rest of us haven't seen, that means you've got a nice little collection of 0 days that potentially you're sitting on, or the customer would discover, right? You don't have to answer. You don't have to answer that. By the way, that's really awesome. Very cool stuff. For our listeners that would like to learn more and get a demo and/or trial, you can visit securityweekly.com/vicarious. Roy and David, thank you so much for appearing on Paul's Security Weekly and staying up really late to do the show live with us. So thank you very much.
Thanks. Thank you so much.
Thank you.
And with that, we'll take a short break. Come back with our next interview with Sumedh from Qualys. Stay tuned.